Hi everyone, we're going to determine the points at which the graph of the function has a horizontal tangent line. And the first thing we're going to do is take the derivative of y, and that's going to be 4x cubed minus 16x. And then we're going to factor out an 4x here, and you get x squared minus 4. I can factor this out further. You get 4x. This would be x minus 2 times x plus 2. And we want our derivative to equal 0. So basically, the horizontal tangents would be at, we have 0 here. Here is 2. And here is negative 2. When you plug this back into our original y, by plugging 0 here, I'm going to get y equals 0 minus 0 plus 2, so that gives you 2. So the horizontal tangents occur at 0, comma 2. If I plug in 2, I get y equals 2 to the 4th minus 8 times 2 squared plus 2. So at 2, we are at negative 14. And then if you plug in negative 2, what happens is, since these are to the 4th and squared, we get the same negative 14, because you're squaring out the negative. Okay, and that's basically all you have to do. I have a few more problems. We have this one here, so the first thing we want to do is take the derivative of y, and you get 3x squared plus 1. And then this is going to be always greater than 0 for all x. Okay, so it's always greater than 0. Therefore, there are no horizontal tangents. Because you can't ever set it to 0 because there's no real x's. Okay? And this one, first take the derivative. I'm going to rewrite it. This is x to negative 2. Therefore, the derivative of y would be negative 2x to negative 3. And that equals negative 2 over x cubed. So that's your derivative. And now, when you look at it, we know that when you have negative 2 over x cubed, we can't have a 0 here. It's undefined. So therefore, there are no horizontal tangents. All right, the next one is this one. So first take the derivative. It's going to be 2x. It's the derivative. And then we want this to equal 0. Only way that can equal 0 is if x equals 0. So when x is 0, you plug it back into your original equation. We get y equals 1. So the horizontal tangent is at 0, 1. The next one is the sine function. The domain's restricted from 0 to 2 pi. And the derivative. And so when you take the derivative of this, you're going to get, let's see. Y, the derivative of y, derivative of x is 1. Derivative of cosine is, sine is cosine. So it's going to be cosine of x. You set this to 0, so you get cosine of x equals negative 1. Cosine x has to be at pi. because cosine of pi equals negative 1. So at x equals pi, so we're going to plug that in to our original equation and see what my y is. So well, y equals pi plus sine of pi. Sine of pi is 0, so we get pi plus 0, and so our horizontal tangent occurs at pi, comma, pi. And our last one is this one, and so we're going to take the derivative, and the derivative of x here is just going to be 1, so we just get the square root of 3. That's our constant. Derivative of cosine is negative sine, so it's going to be minus 2 sine of x. And we're going to set this to 0, so we get negative 2 sine of x equals negative square root of 3. So sine of x equals square root of 3 over 2. Now, we have two solutions for that. X could equal pi over 3, or x could equal 2 pi over 3. So we plug both of these in to our original equation. So we want to know at x is pi over 3, what would be my y? And at x equals 2 pi over 3, what would be my y? So I plug that in. I get y equals square root of 3 times pi over 3 plus 2 cosine of pi over 3. So that's going to give you, this equals square root of 3 pi over 3 plus 2 times 1/2, which equals 1. And since that equals 1, I can write this as square root of 3 pi plus 3 over 3. You can write it like that, or you can write it like square root of 3 pi over 3 plus 1. Alright, so that would be 3, I need to save room here. So this is going to be 3 pi plus 3 over 3. Alright, now if I do 2 pi over 3, I'm going to get, let's just do it over here. If I do 2 pi over 3, I'm going to get y equals square root of 3 times 2 pi over 3, okay, plus 2 cosine of 2 pi over 3. Alright, so this equals, let's see, this is going to be 2 pi, whoops, 2 square root of 3, I'm moving these around, 2 square root of 3 pi over 3, and this this right here is 1/2. 2 times 1/2 equals 1, so this will be plus 1. Or I can write it as 2 square root of 3 pi minus 3 over 3. This should have been minus here. Alright. And so my point would be 2 pi over 3, comma, 2 square root of 3 pi minus 3 over 3. Or you could write this there instead. And that's all. Thank you and have a nice day. Bye-bye.